Section 12.4, cross product of two non-zero vectors. Just a little background. Those of you know what matrices are. So there is this concept associated with a square matrix. Square matrix is the type of matrix which they have same number of rows and same number of columns. In other words, 2 by 2 matrix considered to be a square matrix, 3 by 3 matrix considered to be a square matrix. So associated with the square matrices, there is this real number called determinant. And usually the notation is the determinant, det of a matrix A, or sometimes they just write the elements of the matrix inside a couple of bars, like absolute value bars. So the definition of 2 by 2 determinant is what? A1 B2 minus what? B1 A2. So you kind of go like this and subtract the result. And the order matters. For 3 by 3 is a little bit tricky. So you gotta take what? The element of each row and kind of do a row expansion. This is called cofactor expansion about any row or column for 3 by 3. So the bottom line is these guys have hidden signs. So you start with plus and then you alternate the signs. So what's happening is if I would have kind of expand this determinant about the first row, so I have to include those invisible signs for A1, A2, A3. And once you multiply, so you determine the signs, then you multiply each of these elements by their minors. And minors is a 2 by 2 determinant, okay, which is found by kind of deleting the row and the column which that element is located. So if I delete first row and the first column, I'll be left with B2, B3, C2, C3. Now I have to find the determinant of these this 2 by 2 matrix. So the saga continues till you get to the end, and then lo and behold, this would be the final result. However, the shortcut is if A is, let's say, A1, A2, A3, and B is what? B1, B2, B3. So the definition of A cross B is a 3 by 3 matrix, which the first row is always the standard unit vectors, I, J, K, and the second row is like the first vector, and the third row is the components of the second vector. Notice the order matters. So if you have A cross B, the elements, the X and Y and Z component of A has to go first in the second row, and the components of B, like, X and Y, Z component, has to go in the third row. So the order very much matters. So what is A cross B? Geometrically, what does it represent? Well, it's a vector. So the answer here would be a vector. Okay, so the cross product of two vectors, non-zero vectors, is a vector, which happens to be perpendicular to both A and B. So it's a vector which is perpendicular, or sometimes they use the word orthogonal in general sense, to both A and B. For instance, if vector A is 4, 3, -2, and B is 2, -1, 1, there are two parts to this problem. One part is, can you find A cross B? Remember, that's just a way of multiplying, a different way of multiplying vectors. And then B cross A, if what happens if the order changes, and verify that A cross B is orthogonal to both A and B. Orthogonal means perpendicular. So let me just do part A, which is kind of like, okay, so this would be I, J, K, 4, 3, -2, 2, negative 1, and then 1. Okay? So this would be the same as saying A cross B. Remember, the answer is supposed to come up as a vector. So I'm going to take the first row and do the cofactor expansion. Remember the signs. This is always positive, that's always negative, and this guy is positive. So I'm going to get positive, negative, positive, correct? So now that would be positive I times the 2 by 2 determinant, negative J times 2 by 2 determinant, and positive K times a 2 by 2 determinant. How do you know what would be the elements of these determinants? Remember, you delete the row and the column which that element is positioned, and see what's left over. So that would be the elements of the resulting determinant, which is called the minors. So in this case, if I delete the first row and the first column, here I get what? 3, negative 2, negative 1, 1. Here for J, I have to delete the first row and the what? Second column. That would leave me with 4, negative 2, what? 2, 1, correct? And for K, I have to delete the first row and the third column, and that would leave me with 4, 3, 2, negative 1. So if I go through this computation, 2 by 2 determinant is computed by this formula, A1, B2 minus B1, A2. So in this case, I get 3 minus 2 minus J, 4 plus what? 4, and then I get K times negative 4 minus 6. So I get I minus 8J minus 10K, which I can write it as 1, negative 10 in what? In angular brackets notation. So there it is. So this is what? A vector. Do you see it? So notice the cross product of two non-zero vectors is a vector. So what's going on? Well, if this is A, and let's say this is B, A cross B, so you have to kind of like put your fingers like this on vector A and kind of fold it towards B, and whichever the thumb is what? Pointing, that will be the direction of the what? A cross B, which is perpendicular to both A and B. So once again, put your fingers like this, your palm of hand like this, along the vector A, and then bend the vectors towards the second vector and see which way the thumb points, and that would be the direction of A cross B. So the question is, does the order matter? In other words, what if I change the order of what? Cross product. So instead of A cross B, what if I go B cross A? In other words, what if I go I, J, K, and then instead of listing the components of A first, what if I list the components of B first and then A later? Turns out the answer will be almost the same as what? Part A, except what? The signs will change. So in other words, one of the properties or rules of A cross B immediately, which you can discover this on your own, is what? Cross product is not commutative, meaning A cross B is not the same as B cross A. It's opposite of it, as you can tell by our example here. So what is the geometric significance of A cross B? Well, remember, A cross B is perpendicular to both what? A and B vectors. So how do you know that? Well, remember the definition of perpendicularity. Two vectors are said to be perpendicular if their what? Dot product is what? 0. So that's the definition of A vector to be perpendicular to B vector. So all you have to do is what? Take A cross B and dot it with A, and later dot it with B, and see if you get 0. So that just shows you that what? The cross product of two non-zero vectors happens to be a vector which is perpendicular to both of those vectors. Okay, in this case, I had, let's see now, from part A, I had 1, -8, -10. What was A? A was what? 4, 3, -2. Let me take the dot product. 4 minus what? 24 plus 20. So that would be -20 and plus 20 is 0. And this guy also gives 0. So that kind of confirms the fact that cross product of two vectors happens to be a vector which is perpendicular to both original vectors. Okay, sometimes we're interested, like in application problems, excuse me, in the length of the vector A cross B. Turns out, if you have two non-zero vectors, namely A and B, with theta, which happens to be the angle between A and B, so here's A, and here's B, and here's theta, right? The cross product is a what? Is a vector which is perpendicular to both what? A and B, correct? Question, what would be the length of this vector? Answer, the length of the vector cross product of two vectors, A comma A cross B, that's how you read this, A cross B is magnitude of A times magnitude of B times sine of theta, not cosine, but sine of theta. So what happens is the consequence of this theorem, it is if theta is 0 or pi, sine of 0 or pi is 0, therefore, that shows you what? A is parallel to B, because if this guy is 0, the magnitude of the cross product is 0, that implies the cross product itself is 0. So now we have two ways to see if two vectors are parallel. To see if two vectors are parallel, either you take their cross product and see if you get a 0 vector, not 0 the number, but 0 vector, or previously we found out if a vector is a scalar multiple of a different vector, then they are parallel. So there are two ways to check and see if two vectors are parallel to each other. Either their cross product has to be 0 vector, or one vector has to be a scalar product of a different vector. Scalar meaning any real number. So here are the properties of the cross product. As we mentioned, cross product is not commutative. A cross B is not the same as B cross A. It's opposite. KA cross B, you can write it as KA cross B or A cross KB, where K is constant. A cross B plus C is what? A cross B plus A cross C. So please keep track of the order. Okay, so don't mess up the order here. Follow the order. Incidentally, A cross A is 0. Why? Because any vector is parallel to itself, and we just found out if the cross product of two vectors is 0 vector, they must be parallel. And since a vector is parallel to itself, because it's a scalar multiple like 1 times itself, therefore it's parallel, so it's 0. A plus B cross C is A cross C plus B cross C. Keep track of the order. This is called right cross multiplication, and this is called left cross multiplication. So this is right cross multiplication. This is left cross multiplication because you're multiplying the summation on the left side, and you take in the cross product. Here you cross producting a summation by a vector on the right side of the summation. A dot cross product is not A dot B cross A dot C. Be careful, it's A cross B dot C, which this is known as what? Scalar product of A and B and C. So this is scalar triple product of A and B and C, which we're going to use this momentarily. So remember, A dot B cross C is not A dot B cross A dot C. It's A cross B dot C. Be careful. And finally, if you are taking the cross product of the three vectors, it's not A cross B cross C, it's equal to A dot C. That means dot product B minus the dot product of what? A and B and times C. So just see how this works in some application problems, namely finding the area of a parallelogram. Remember, area of a parallelogram is what? Area is equal to base times height. So here is the base, here is the height. Is that right? So how do you do this? So the area equals base, which is magnitude of A, times H, correct? But what is H? H happens to be what? Magnitude of what? B times sine of theta. Can you see it? Because sine of theta is opposite over what? Hypotenuse. So therefore H is what? Hypotenuse times sine of theta. Well, wait a minute, what is this equal to? Remember a minute ago we said that's exactly the same as the length of the what? Cross product. In other words, this is exactly the length of A cross B. There goes the area of the what? Parallelogram. So take the cross product of these two vectors. So specifically, let's say I have vectors 0, 1, 3 and 2, 5, 0. Take their cross product and then take the what? Its magnitude. So that would be like kind of like the way to do this. So let me just see if I have the answer here. So let's say A cross B, which is what? I, J, K, let's say 0, 1, 3, let's say 2, 5, 0. Remember, these are given. So that gives me what? Negative 15, 6, and negative 2. But remember, that's not the area. The area of a parallelogram is what? The length of this vector, which is the square root of, what is it, 225, is it? Plus 36 plus 4, which gives you square root of 265, which is about 16.28 what? Square units. Is that right? Like cubic unit, like, you know, square inches or square feet, whatever the area is. How do you find the area of a triangle, knowing the area of a parallelogram? Well, triangle is half of the parallelogram. So the area of the triangle can be obtained by finding or dividing the area of a parallelogram. So in this case, half of what? Square root of 265. That gives you about 8.1 square units. Do you see it? So that's how you find the area of a triangle. Find the area of a parallelogram using this formula, and then divide it by 2. Lo and behold, you have a what? Area of what? triangle. Okay, how do you find the volume of a not perfect box? Remember, it's like someone has stepped on this. Usually volume is computed by multiplying length by width by height. Problem is the height is slanted here, so you can't use this formula, so you have to manipulate it. So how do I do this? Length times width is this much, so that would be the area of the parallelogram. Parallelogram, is that right? Times height. But the height is not vector c. The height is this guy. It's on this line, right? Because the height, whatever the height of the box is, it has to be perpendicular to all these vectors, correct? So, but it's not. Notice C supposedly is the height, is slanted, so it's not perpendicular. Do you see it? It's not perpendicular to the height, to the area. So, what do we do? Well, first we find what? A cross B, and then height. How do I find the height? Well, first I have to know what this vector is. This vector can be computed by A cross B. Notice if you multiply, take the cross product of A and B, you get a vector like this guy, is that right? Which happens to be perpendicular to both A and B. Now that can be considered as to be height, right? Okay, like a, axis which is perpendicular. But what is the height? Height is this much. Do you see it? So how do I find h? Well, remember, h is the same as what? Scalar projection of C onto A cross B. So this would be what? A cross B magnitude, the area of the base, times scalar projection of C onto what? A cross B. Okay. Well, what is the scalar product of what? C onto A and B? Well, it is what? Absolute value of C times what? Magnitude of A cross B. Excuse me, guys. Let me just try that one more time. So that would be like magnitude of A cross B is what? C dotted with what? Magnitude of A cross B. Oh, Jesus, it's not. Dotted with A cross B, sorry, over magnitude of A cross B. Do you see it? So this is just the plain dot product. So these guys nicely cancel. And lo and behold, you get volume of a not perfect box is what? Is C dotted with what? A cross B. And because this is volume, so it would be nice to take its absolute value. And this would be so many what? Cubic units. Do you see it? And this is exactly the same as what we just learned a minute ago. It's called scalar triple product. So there you have it. Okay. Next item is this guy. So what would be the cross product of the what? Standard unit vectors, ijk. So make a what? A 3-hour clock, and it goes what? Clockwise, like so. So I cross j gives you k, j cross k gives you I, k cross I gives you j. On the other hand, if you go counterclockwise, I cross k gives you what? Minus what? J, k cross I, if you go counterclockwise, gives you minus I, okay? But I cross j gives you positive k, j cross I gives you what? minus k. Do you see it? And k cross I gives you what? What? J. So if you go clockwise, it's positive. Counterclockwise, counterclockwise is what? Negative, correct? So clockwise is positive. I cross J is positive K. But if you go counterclockwise, it's negative. I cross I is zero vector. Why is it zero? Because what? Vector I is parallel to itself. And by definition, we know these guys are what? Their cross product is zero. The next application is about torque. What is torque? Torque is the measure of tendency of a body to rotate about the origin, just like when you push a door and you open the door. Incidentally, torque is also known as moment of force. Okay, a typical example of the torque is like, you know, loosening up a bolt. So when you take a wrench like so, you apply a force, you know, somewhere on the arm of this wrench, and you try to what? Create a rotation in order to loosen up the bolt. So the question is, that creates torque, and we like to find its magnitude. So by definition, torque is defined by what? By what? R, which is position vector, cross what? Force. So remember, you gotta follow the order. It's always position vector cross force, not the other way around. Otherwise, you would be like tightening up the bolt and you might break it. So it has to be like so in order to loosen it up. Okay, so we will be interested in what? In the vertical component of the force. Remember, force is always applied what? Perpendicular to the arm, not horizontally, because if you apply the what? Force horizontally, nothing happens. So you have to apply the force what? Perpendicular in order for it to create a rotation. And that creates ultimately a torque. So the only component of F that causes rotation is the one which is perpendicular to R. That is F what? Magnitude of F times sine of theta, not cosine of theta. And theta goes from 0 to pi. And theta is the angle between the what? Position vector and the force. And remember, theta always goes from R to F, not F to R. If you draw a line going through the force, extend the force line, that's called line of action. And if you extend the arm here of the wrench, that's called what? Moment arm of force. And also that axis, which is drawn by extending the arm of the wrench, it's called rotation axis. So here's the deal. The question is, find the magnitude of the torque, which is applied by a force, and the magnitude of the force is 30 newtons, and the length of this arm of the wrench is 0.4 meters. How much torque is what? Applied to the center of the what? Bolt. So to do this problem, what we need to do is what? Kind of like recite the formula, which is torque is R cross F. But remember, I'm interested in what? Magnitude of the torque. Incidentally, this is called ta, which is a Greek letter, as indicates torque. It's called ta, T-A-U. Okay, so magnitude of ta, which is the magnitude of the torque, is magnitude of R cross F. But magnitude of R cross F is magnitude of R times magnitude of F times the sine of theta. Remember, this is vertical component of the force. Okay, vertical component of the force. Okay. Horizontal component has to do with motion. Vertical component has to do with rotation, correct? So in our case, the magnitude of the wrench is what? 0.4 meters. And F was 30 newtons. And theta here was given to us as 65 degrees. So the magnitude of force is 30 newtons. Angle between R and F is 65 degrees. And length is 0.4 meters. So this would be like what? Sine of 65 degrees. So if you kind of sort of work this out, what would you end up with? You would end up with approximately 10.88 newtons meter. Okay. So this is the amount of magnitude of the torque. That's the amount which causes the rotation. Incidentally, if R is in meters, F is in newtons, so the unit for ta is Newton meter, not joules. Joules is reserved for what? For work. If this guy is in feet and this guy is in pounds, so this would be foot-pound. Okay, and these are the only units which we use either in English system or metric system. And that pretty much does it for section 12.4. Thank you.